Hey everybody, welcome to the stream. Hope you're having a good Sunday, and if you celebrate, hope you had a good Valentine's Day yesterday. It was very rainy here, and so we didn't do too much. But I'm ready to get back into splines because they're super interesting topic. At the very least, from a mathematics perspective, you've got some things where it's not regular functional mathematics. You're in multiple dimensions, but like the dimension that is changing is not one of the dimensions that's in the output. I think that's really interesting. Um, so splines. Hi Chris, welcome to the stream. Okay, so last time we left the stream, I hadn't gotten the Catmull-Rom correct. But you can see here, this is the screenshot I posted after the stream last week. One of the things that I was doing wrong, first of all, I was trying to, do this with like materials, and there's like the debug things exist, so why not use those? um, and you can see here that we've got, so the green circles are the control points. And you can see the spline here. So we're only doing one spline segment. But you can imagine if there's another control point added, we would draw another spline here. Depending on where that point is, would determine what the shape of the next segment is. And so we've got basically working Catmull-Rom splines. I'm not really happy with the API. First of all, I think that there might be a case to be made for you can only give me 4 points. And I think that's fairly reasonable. There's some things that I want to do that like I feel like will save me time later. And I want to do those today. And then I think we'll probably do Bezier splines after we get some of this refactored. So what was wrong last time? Well, we had implemented this, right? Which was based off of the C# example, the C# Unity example. And it's fine. But I was looking more carefully at this remap to 2D, and it's basically linear interpolation. And what you've done is you've just changed the t, right? You changed the t factor. So I want to generalize this. And then we'll reframe this in terms of linear interpolation. Okay? Because that's basically what it is. And I almost want to do something where okay, let me take a step back. I struggle with some of this because I feel like this is a place, this kind of operation that generalizes across multiple dimensions is something that things like traits in Rust or type classes in Haskell or protocols in Elixir, those are all built to solve. And Gleam explicitly rejects those. So there are ways around it. I'm not sure I want to make those ways. But what we can do is we can do let's do a lerp module, right? Yeah, so like he was doing some thank you Martin. I think Giacomo was doing some SVG stuff. Like an SVG has splines built in. So this is like a more low level thing than what SVG would show. But I loved his demonstration of the interpolation across the spline. And because that's exactly how you calculate it. Is you draw the lines among the control points, and then and you recursively subdivide it until you've got a linear interpolation across one line segment. So it's a great demonstration of how that works. Very cool stuff. Okay, so since we have splines directory here, we don't have anything in this. I'm tempted to make a lerp module, and I think I'm just going to go ahead and make that. Okay, and hello NNB, welcome to the stream. Okay, so what I want to do is basically take this and generalize it, and then what we'll do is we'll make linear interpolations for 1D, 2D, and 3D. Maybe 4D. I don't have any use for 4D splines, but they could be useful for something. I don't know. Rotations. We'll see. So let's do some lerp. So the basic way to do a linear interpolation would be, and I'm gonna make lerper. I'm gonna make a thing that returns a function. So we don't know what the arguments are here yet, but what we want it to return is a function that takes that takes the input type and a float and returns the output type, right? Okay, and I don't know that that's the right syntax. Maybe let's go pub type interpolator. Is that okay? And this is going to, and this needs a type argument, right? So interpolator A. The veclet map 3, which makes lerp fun. Okay, is that published? Here, map 3, and like this. Okay. I mean, there's map 2. All right, we'll figure this out. We may use that. Okay. Oops, wrong window. I need to close my personal email. Sorry, folks. Okay. So what I want to do is construct this function. So what do we need to do lerp, right? And I'm going to split bottom so we can see this. So we need and we're not passing the values here, right? What we're going to do is pass the functions, and that will construct the function that will do the interpolation for us. So we have a subtract function, which is going to be and that's going to return an A. And we have a scale function. Let's do the add and subtract in that order. Add is going to be another binary function, and scale is going to be a function A and float and returns an A. So we can define a function here, and this is going to be what we return. So it's going to take A and B and T. The problem of naming this A, let's name this I don't use X and Y because that has other implications. Let's use I and J. And T returns a float. And what we're going to do is we're going to do subtract. I'm going to take J, right? And we're going to pass that to scale, T, and we're going to add back I. Okay, so that's basically what we did down here, ignoring the arguments to these functions. Okay, so there's our lerper. Now we can create a linear interpolator. Maybe we'll rename this eventually, but that can operate over any dimension. Higher order functions for the win. Okay, so I want to go ahead and make the 1D, 2D, and 3D. So we are going to import vec 2f, vec 3f. We might, I don't know that we need to do splines for integers. Okay, and then we'll do the same for vec2, and this is type vec2, type vec3, vec3. Okay. You still aren't adding those type aliases, are you? I would love to have type vec3f. Maybe I'll define it myself here. Hello, Renatias. Okay, so what I can do now is I can define lerp1 the thing is this can be I kind of want it to be a constant, but you can't call functions in a constant. So we may or may not use this. We'll see. I just wanted to like define it for the feeling of, hey, you know, I made something generic. What is lerper? Is it an object and not hoop that learns? No, it's somebody who pretends to be the character that they are in real, the character in their fantasy in real life. It's a, but you know, depending on how many dimensions they live in. Sorry if I have to explain that joke. Okay, so we're gonna do lerp1, and it's going to take you know, we'll use the same argument names here. So I is a float, j is a float, and t is a float, and this is going to return a float. Okay, so lerp1 is going to be lerper, and it's going to be plus. I don't know if you can do that. Can you use? We can use float add. Let's, yeah, we imported Gleam float. Okay, float add, float subtract, float multiply. Okay, and then we can call that with I, j, and t. Instead of introverted, you are interpolated. Extrapolation roleplay. Yes, basically. Okay, so then we can do lerp2, and we're going to say this is a vec2 float. I'm going to be that guy. I'm sorry. I'm sorry, NND. I'm ready to be told I'm wrong. I'm so wrong. Sue me. Why are we not formatting? It's probably mad about this. Yeah. Okay, so this is vec2f. J is vec2f. t is float, and we're going to return a vec2f. Yeah, you should add it. I know. Like, I just like, what, do I need to add it in every project? Okay. Okay, so here we're going to say this is vec2f, add vec2, oops, to f subtract and vec2f scale. Right, so this comes out. The thing that I don't care for about this is that I'm creating this anonymous function every time. What I would love to do is create this anonymous function once, or like do something at compile time. And I suppose I can do that. And maybe what I'll do after we get the 3 of these, and honestly it's just a repeat, right? But for vec3s. So let's go ahead and do that. The thing that I don't care for about it is that, you know, again, I'm creating this anonymous function just to immediately call it again. So I should just inline that definition. We had a lerp_est function. The question is, what is the lerpest? I would really love to know. Now, if I were going to anyway, okay, let me take a step back. Let's rewrite this remap 2D in terms of our lerp2, right? So what we want to do is let's import splines lerp. Where'd my remap? Okay, so this is basically lerp2, and our inputs are C and D and this. And that's it. Okay. So should lerp be part of standard lib? No. No, but I think it's reasonable to put it in vec if you wanted to add it to vec. You know, it is a very common operation, but I think the hesitation would be that the definition is actually very simple. And I did this particular formulation of it just because it's easy to have 3 functions rather than go, oh, well, I'm going to do 1 minus t of the first thing and add that to t times the second thing, and like it's just easier for me to do the algebraic transformation and say, well, what you're actually doing is subtracting the 2 and then adding back to the first one. So you know, both formulations are valid. Algebra is a thing. Okay, so now that we have this, I don't like it. What I want to do is leave this in case we need to do something else, and then let's rewrite these so that they're actually direct and not creating an anonymous function that gets reused all the time. There's not really a way to memoize that, so it's, I mean, I could go const lerp1 is this, but it's going to go, no, you didn't. Right? It's like you can't call functions inside constants. So so we're just not going to do that. Okay. The way to make a function constant at the top level is to define a function. So let's just you know, basically do this, and we'll say we could rewrite this as and this is not scale but multiply, right? We could write this as, you know, the base level binary operations, but this is fine. Yeah, it seems like lerp should be in vec. Break the rule sometime is okay. Lerp is somewhat common in vec anyway. Yeah, like that's the thing, is that you know, you're doing graphics, you're doing motion, these sorts of things are frequently used in those domains. So it's reasonable to do them in that library. Okay. Does not have a subtract. What? Oh, vec2f. Helps if I put the F on there. F in the chat. Okay. So that scratched my itch for something to make this more general. And then these will be useful when we do Bezier. Okay, I'm going to break the split there. Okay. So the next thing that I want to do is actually simplify this. My goal was, and when you see this, my goal was to make previously to make smooth paths through all the points. There's a gap in my understanding though. And give me a second, I need to turn the fan on. It's warm in here. Okay, there's a gap in my understanding in that, you know, this computation that we do to get the knots. Oh, here this repetition was making me go, oh gosh, I should do generic, you know, compute the knots. Maybe I should. The problem is, I thought that the knots on this were like in the units of distance or some related dimension, like maybe velocity. But it's not clear to me from the formulation here what the meaning of those 4 knots are, right? So I think it's not reasonable to say, because what I would like to do is be able to map like the game time. For instance, if we're doing a character that walks along this path or drives or, you know, or something like that, I thought we could potentially map the game time onto the curve, right? By scaling it, saying like, what is this thing's velocity? And that velocity would be input into, you know, which 2 knots it's between, right? But I don't think that that's actually how it works. So I think the way out of this is to say that's left as an exercise for the reader. And what I'll do is we'll make the knots into a, maybe we'll make it into a type itself, so we can go T0, T1, etc. We will make, the points will always be 4, right? And then we can simplify this code. So let's do that fairly quickly. Maybe we don't need a type, maybe we just use a tuple. We use a tuple for both of them. So let's go, this is a float, 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 float. And this is, and I actually feel like these types should move up. So let's put it up here. Import splines type vec2f type vec3f. Okay. And we need to copy these into there. Okay. I am kind of opposed to doing util modules, although they're very tempting. Okay, so let's import splines type vec2f type vec3f. Okay. Okay, so this is going to be points is going to be vec2f vec2f vec2f, etc. I'm not going to bother to make this an extra. Okay, and then let's do the same here on the 3D, because we're just going to redo all of that as well. And this is going to be vec3f. Now I could potentially make a generic one and like type aliases and that business, but being those splines internal, yeah, that's possible. Honestly, there's not enough complication here for me to go, yeah, this needs to be. The interesting thing about that is we can reformulate this such that it doesn't need to use a result. Very nice. So let's go. Let's rewrite this. So this is P0, and we're just going to do that over and over. So 1, 2, 3, right? And then we can get rid of that. Let's get rid of that. We don't need OK. Okay. So we can go, this is easy to start with. P0, P1, P2, P3. Okay, so there we've already got the points that we need. The knots is a little bit more complicated, but not too bad. Since we don't have this in a list, we don't need to do windows. We can just do this inner part 4 times. I don't see any problem with that. So what we're gonna do is get K0 here, and let's just do it like this, K0T, and we'll put this in a block. Distance, and this is going to be P0, no, P1, P0, is that right? No, P0, P1, actually doesn't matter, but we'll do square root, and then we don't need to. The T just comes through. These are the knots, right? I think this construction kind of makes it difficult. So let's just do K0 is this. Okay. So that means K1 is we'll do something similar to this. And this is going to be implicitly there's a 0 plus because that was the beginning of the accumulator in this iterative form. Okay, so this is going to be P1, P2, and then we'll do K0 plus T. Okay, and then this is going to repeat. And that's going to be way easier. Okay, so K2 is going to be between P2 and P3. What am I getting wrong? Oh no, window by 2, so there's only 3. So this is actually K1 because K0 is always 0. Yep. So this is going to be K1, this is going to be K2. Okay, so now we know that we can get rid of this. Okay, and the knots are going to be 0, K1, K2, K3. Okay, and that's a much simpler construction here. And we don't have to have this get knots function. Just, you know, get rid of it, right? Okay, what's wrong with that? I didn't mean to wrap it in okay, because we cannot fail anymore. The only way we would fail is if the square root fails. Okay. Now we can simplify the 3D one as well. So let's just copy and paste. And just change all those. Easy enough. Okay. And this is vec 3f. Vec 3f. And, you know, at times I would have said, hey, we need to, you know, make this particular thing a function, but and not repeat it, but it's fine. You'll be fine. Okay, so yeah, we don't need that. What we need is let this is curve.points, and this is curve.knots. So we can simplify that. Okay, and we can get rid of that. That feels so much better. Dry is an anti-pattern these days. Yes and no. Like, I think that for me, sometimes thinking of in terms of the repeated operations as functions I can call, that helps me think about what I'm doing. But that's just my like functional bias. Yeah, so now we can take these two functions and we can do them for 3D really quickly because we simplified that. So this is vec3 float. And you know, I don't know that I might want to add clamp to this, but let's just change these to 3D and 3D. We'll rename this to 3D. And here since we brought in that alias, we should just go ahead and use it. And this is vec3f. So when we're done with this little cleanup, I want to make sure that our example still works, and then we'll do, see, that wasn't hard at all. We'll do Bezier splines, because those are fun too. Okay, and we don't need Gleam list anymore. Very nice. Let's refresh our example. Did I save it? Here, what's going on? Let's see, we've got some problems. Okay, let's jump to the warnings. What are you complaining about? You're not importing Savoiardi. Wait, what's wrong here in lerp, first of all? Oh, we're not importing those types anymore because we're using the ones at the top level. Yep. Okay, let's go here. Right, so because I didn't, you know, that extension wasn't really there. Fine. Because that lines extension wasn't there. Oh, and this needs to be, let's just inline those because they're actual arguments now. Yeah. Just paste those in there and be done with it. Except that, yeah, we need points for the actual showing of the curve. We just duplicate that. It's fine. And yeah, so what we could do potentially is play with how many segments and like see how that affects it. Like we could start with two segments, 0 to 0.5 and 0.5 to 1. We could pick irregular ones. Yeah, so let's see if it'll start up. It started. Okay, and we're still drawing, so we didn't break anything. That's good. Let's cut down. Let's cut it down to, obviously one segment is not going to help. That doesn't make any sense. Let's cut it down to 3 segments. And you can see it's a little bit chunkier. I'm sorry, that's a little small. How can we adjust that? I could change the camera, I guess. Anyway. Okay. So, Catmull-Rom. Let's put those segments back because I actually want it to look fairly smooth. It's interesting how 10 subdivisions, at least at this resolution, is not that bad. Like it looks smooth. I mean, there's some issues with aliasing along that line, but it looks like, that turn doesn't go chunky. It glides into it. Very nice. Okay. So, one down. Let us look at Bezier. There are 2 different kinds of Bezier splines. Well, okay, there are at least 2. The 2 that you usually see are how to put it? They are the one I'm most familiar with is cubic. So cubic has 2 endpoints and 2 control points. If the control points end up on the same point, you've degraded it to a quadratic Bezier spline. So we can expose both cubic and quadratic, or we can just say, well, you're getting cubic, and if you give us the if you give us the control points are equal, we just do less math. I actually think it might make more sense because of the way that the algorithm works, that if you have fewer points, we start with fewer. Let's now you can do higher dimensions than cubic, not higher dimensions, higher orders, but they, as I understand, they get a little bit unpredictable. We're going to go back to Wikipedia and let's see if they have just a link I can jump to. Nope, not from this page. Okay, so let's look at Bezier splines, Bezier curves. Okay, so here's a cubic. It's got 4 control points, 2 of which are on the curve. Basis functions, I never understood that. I'm going to ignore that. So linear Bezier curves, it's just a line, right? And your interpolation along that determines, so this is basically linear Bezier curves degrade to linear interpolation, right? Quadratic, you get a control point out here that changes the shape of the curve based on, these where it is positioned relative to the other two control points. So if you look at, it's, parabola is the wrong word, but like the feeling I want to go to is, oh, this is a parabola. It's not. It is a parametric curve. It's just the number of operations you do with t is 2, right? So okay, so there's a general definition. These are all the maths things, and what I wanted to get down to was, yeah, and this is probably the same thing that Giacomo was showing on his stream, is that you can see in this construction, you're linear interpolating along from P0 to P1, and also at the same time P1 to P2, and then from that you construct a line segment that you interpolate along T, and that's where the point on the curve is, right? What was the name? Chris, do you happen to remember the name of this algorithm? It has somebody's name, and when we did it at Fable, I used this and as the name of the function that you would call. But you basically, what we're going to do, regardless of, so here's cubic, same algorithm, except that you take one more step, right? We're not going to do fourth order curves or fifth order. Like, who uses that? Most people are like, cubic is good enough. And what would you use this for? Like, drawing shapes is the big thing, I think. But who am I to say what you would use it for? But like, look at how intricate and complicated this becomes at quintic. Like, I can't even, heck, quartic is like hard to conceive of. The Castle-Yao, thank you. Thank you, Chris. Oh my gosh, I don't know why. Anyway, that's the method. Okay, so what we can do is we can define this. Thank you. We can define this recursively. So what we're going to do is we're going to make a private function first. And I'm tempted to call it de Castle-Yao, but I think I want to call it, yeah, let's call it de Castle-Yao. I always misspelled that. It's an awful name to try to spell. Okay, so what we're going to do is this is going to recursively operate on these, and it's going to we're going to have it pass in a lerper, and I think this is where it'll get good, because we don't have to think about what the dimensions of the spline are, right? Like, what's the output dimension? Yes, he was Giacomo Cavalieri was on stream doing that. Okay, so we're gonna take these are the control points, and this is gonna be a list of A, and then we're gonna take an interpolator, and here's where we'll go import splines lerp type interpolator, right? And this is going to be an interpolator over A, and a T is a float, and this is going to eventually return an A. Okay. So what we can do is we can match on points, and if it's empty, we've done it wrong. And I think we should panic. We'll just say it's invalid input. You gave us something wrong. Okay, but if there's only one, then that's the result, right? And we'll return 1. If it's any other number of points, then we're going to go through and produce a new set of points, which is the interpolation between every successive point in here. So, and then we'll pass that into... so we're basically going to do some algorithm, which we'll replace later. And we're going to pass that to itself. Interpolator and t, right? So we're going recursive here, folks. So we have the base case. This is the base case. This is, you're an idiot, you called us wrong. So what do we want to do here? We know that this needs to return a list of points. So we're going to do something similar to what we were doing in that Catmull-Rom. And I think... Okay, Gleam standard lib. Let's look at list. And I think it was the window by 2, right? Okay, so we're going to go points list dot window by 2. Okay. And then we're going to map over that. And this is actually really simple. So this is going to pass, this is going to be tuples. And what we're going to do is we're going to call interpolator pair.0, pair.1, t. And we did it. That's basically it. Now it's just complaining that this is, you know, unused, right? We can get rid of the brackets now. Okay, so what is this saying? We have a list of points, so this will work for an arbitrary Bezier curve, right? And if there's only one point, then we return that because you can't interpolate between on t over 1 point. If there's more than 1 point, then your next job is to interpolate between the pairs of points in that list and produce a new list, which is the set of interpolations that you've just computed, and then pass that back in so that you're eventually reducing it down to there's only one left. Okay. Seems like everyone is playing with curves lately. Yeah, I mean, curves are fun. What's wrong with playing with curves? Okay, so there's a question now in my mind of whether we just let you construct any kind of Bezier. Why not? Right? Why not? I mean, I think in the Catmull-Rom it was maybe a little more complicated. Maybe we could say that you could... Okay, so the problem here is we needed, in the Catmull-Rom, we needed to know what the inner type was. Now we could potentially make this generic in that you could pass an interpolator, and maybe that's what we do. Okay, so let's make okay, so we're going to make a new function, and this is going to take the list of points And we'll say this is a Bezier of A. The thing is, it's going to have to take an interpolator as well. I don't really like this, but this is if you want to do your own thing. But let's go ahead and make... we're going to have to import our type alias as well. Okay. So let's make... We're going to make this opaque. You know what? It doesn't need to be opaque. Because what we're going to do is we're going to say... Yep. Can I spell? No. Okay, so I actually want to do it like this. And then we'll get rid of this function because you don't need that, okay? But then we're going to make a one that makes 2D, right? And we'll make one that makes 3D, and then that will be enough for now. So this is going to return a Bezier of vec2f. And this is really simple. We do points, and we say interpolator is lerp.lerp2. Oh, I need to fix that. Okay. I was like, what's going on? Okay, and then we need 3D. So let's make a 3F. Easy enough. Lerp, lerp3. Okay, so now I'm going to make a... The question, maybe we say get point, or maybe we say sample. What's a good name for this function? What I want to do is actually call this de Castelgao function. Right? That's basically what it is. Sample's not the right word. It's not a bad word for it. Any ideas? Like in the Catmull-Rom when we did, get point 2D, I guess we could call it get point. Let's look at the literature real quick. What do they say? Progress. They're calling it... Yeah. Stroking. No, okay. Symmetrically distance offset curves. Oh, okay. So that's like drawing a, yeah, okay. Drawing a stroke and filling it. The other thing that we could potentially do in here, which is like, if we find there are a number of points which are equivalent or roughly equal, then you can do degree reduction. That's what they're talking about here. So like a cubic Bezier curve becomes a quadratic one when the control points are equal. So we could do that automatically. The problem is, you know, especially when we're dealing with floats, we have the challenge that floats that are equivalent are not always equal. And you know, you have to consider the error factor on the float, or whatever your chosen tolerance is. So okay, again, I don't think we've answered this sample. Is that an okay name for this? Maybe. The other thing is we need, it's not technically required, but it's generally a good idea to clamp T from 0 to 1. New Tiramisu post in the Discord just finished drafting API for physics in the web component branch. Oh, interesting. Coco. It's gonna be hard for me not to see Coco and think, oh, the Apple UI framework. Sorry, I know that's not what you mean. Ooh, I like that. It's just like attributes. That feels good. Very cool. Okay. Interesting. Okay, now for the now that we have Bezier, I feel like we should have some tests. And there's a serious question in my mind whether whether I can create realistic tests, and I may have to pull a test suite from somewhere else and adjust it. Okay. Using the bit. Okay. Oh, we'll look at that later. Yeah, given we called this sample, it almost feels like we should go back and rethink this. There are limitations on making this generic. Obviously, on all of these things, there are limitations. Okay, it's just complaining about it not being used. But I'm starting to see how some of these things could be completely rethought and made more generic. And that's feeling a bit exciting. So we're going to make an interpolator here as well, because we're using that lerp.interpolator a. Let's think about how that would work. So to construct it, you need this distance thing. But since we're only exposing new 2D and new 3D, what I'm trying to get to is make this generic, right? And we can get rid of the result there as well. Yeah, I'm trying to think of like make this generic, these two functions. Because they just rely on whatever interpolator is appropriate for that data type. So let's just rewrite them. And I'm going to call it sample this time, because I think that that's appropriate. T float. And we're just going to get rid of the result bits here. So let's do, this is going to return A. Okay. And then we can do something like this. And we can do this. And then let's define remap. And that's going to take an argument that is the interpolator for A. Right? And this return A. So what we can do is say this is interpolator. Call that. And then we'll have it generic, and we can just, you know, redo all this. And we'll make use of column edit. Okay, and then we're going to throw in here curve.interpolator as the last argument. Should probably be the first argument, but that's okay. Now we could inline this again. That might be nice. Let's actually look at that. Maybe not, because we're passing different arguments here. I think it's fine to leave it. Otherwise I have to go, well, which one's you, which one, you know. Yeah, B minus, yeah. I would have to inline all of those. I'm not going to bother right now. Okay, so now we have a generic one. Let's get rid of that and get rid of that. Yay for simplification. Okay, so here we're going to say this is new Catmull-Rom vec3f. And our interpolator is going to be lerp.lerp3. And then let's do the same for 2D. Okay, now you're no longer used. Nice. Love it when a plane comes together. Okay, and this is going to be that. Interpolator is going to be lerp.lerp2. And now 2D is unused. Okay. Pretty cool. It's paying off. So now we don't use that. We don't use that. Now we are using these, you know, these functions that are not generic. And I think that since we've made this opaque, there's not a reason to expose something that we don't want to expose yet. And if folks want to do their own thing, then they can send me a patch. Okay, so let's go fix our example because it's surely broken now. We've done a lot of, yeah, so what we're going to do is we're going to change this and we're going to say sample because it no longer returns a result. PR is accepted. Yes, exactly. See, Chris, you understand. You understand. All right. And then let's, yeah, no errors in the console here. Let's just, for argument's sake, restart it and make sure, yeah, it's fine. Okay, so we didn't break anything in the example. Good deal. I'm tempted, before we go on to do something else, to make another example. I kind of don't want this extra mess. Might want to put them in the same project. Yeah, we can delete that. We don't use that. Yeah, we got rid of that business. Okay. Because we're using debug, which is fine. We're only trying to demonstrate the curve. Okay. Think about this. Honestly, I think we probably just could copy. I'm mostly concerned about taking on too much complexity just for the examples. All right, we're gonna do a big rename. Okay, so we're gonna rename this directory to, oh, not that one. How do I expand? There we go. We're going to rename it to showcase. And then let's rename this to showcase. And rename this to showcase. This is just an example. It doesn't matter what it's called. Okay, and then let's clean up. And we're just going to, for the sake of, does this have any output artifacts in it? No, it just has bun. Okay, that's fine to leave. All right, so that'll make this easier. And then this, I want to break it up a little bit. So what I want to do is switch between the examples when you like press a button. So so we're gonna make that happen. Let's go ahead and we're gonna make a new file. Let's make a folder, showcase. Make a new file, Catmull-Rom. Okay, and then we'll make one for Bezier, right? And what we're basically going to do is put the demos in here. So like we're going to take this view function, and really I think what I want to do is just have it return we'll keep the background the same across all the views. I just want to have it return this. So yeah, let's extract that out. And then our model is going to be just enumerating the displays. Okay, so we'll start with, and then when we've got, we'll figure out key bindings later. Maybe we can handle that in tick, send an effect or something, and have it rotate between these. It won't be too bad. Okay, so let's do and I don't know what, here we're just gonna let it return all that. So we need to import some stuff. I'm just going to copy all the imports from here and we'll put them at the top. And then it is not compiled. Here, I guess I need to save. Okay. Yeah, so now we can go case model. Okay, so Bezier's to do. Catmull-Rom, we're going to say import showcase Catmull-Rom. And we'll just do this typical. There, easy enough. Okay, and then here we're just going to return an empty list until we've got that working. So let's have it actually start with that, so we can make sure that this refactor didn't break anything, and then we'll start it with Bezier and see what we can build. But it's going to have a very similar structure to this. Okay, so we don't need option, don't need those things. Yeah. Okay. All right, and then let me restart. We have to rebuild everything. It's fine. And let me make sure that that's correct. Okay. Okay, and we're still displaying the Catmull-Rom. So that's working. Good stuff. All right, so I want to make some more messages here. And we're just going to call it next. And I think that we need to do something here. And next is going to be, we're just going to handle case model. We'll say let model is this. Add the missing patterns, and here we'll just make it go to Catmull-Rom. If we're on Catmull-Rom, we'll make it go to Bezier. And when we add more splines, we can so we want to make sure that it ticks after you've done that, right? And that's, we'll figure out how to trigger that. Okay. So let's look at the Tiramisu docs real quick. So, input. What we'll do is we'll say, we'll use this. Input is key just pressed. That's fine. Okay. Then we want to say effect.dispatch next. If it's not, I'm sorry, we don't need that comma at the end there. Some days I just don't know what language I'm in. Okay. All right. And this will be effects. And we won't change the model in tick. I think that there's a question here where whether I need to call tick. I probably do. I need to dispatch tick every time around because we may never come back to check. Let's use a spacebar. Yeah, so I think let's do effect.batch. And now that we actually need to check the input again. And I think that I want to queue that up first. So thinking of getting rid of the input module for the web components branch, you have more control of the clusters. Yeah, that's fine. I mean, like this, this is just for demo. I'm not making a real game from this. This is just the demo. Okay, so what we should see, if I did this correctly, is, so refresh, starts as Catmull-Rom. Hit space, we're not drawing anything because we haven't defined Bezier. Hit space. Yeah, it didn't go back. So I've got something wrong here. Yeah, I don't know what I'm doing wrong here. Maybe the issue is let's switch this to effect none. Yeah, that's the issue. I dispatched tick again, and it didn't like that. Okay, so now we're displaying Catmull-Rom. We probably want to put in here like some debug text to show, not this one, in here, some debug text to show what we are, what kind of curve we're displaying. But let's go ahead and get Bézier's done. And it's going to be a similar function to the Catmull-Rom. So we want, heck, let's use those same points. Or, I don't know. We might have some interaction later. Okay, so I'm going to just dump these in here and then we'll fix it. And my cat wants in desperately. He wants me to give him his snack. I don't know if y'all can hear him yelling at my door. Okay, so we're going to use Bézier. The nice thing about this is Bézier, we can say new 2D and just give it points. And we don't have to splay them out again. The Catmull-Rom, oh yeah, I know. Like, you're just wrong. Okay. Bézier.sample. Okay, so there's Catmull-Rom. We're not calling this function yet. We just made it compile. So no. Okay. So now we can do the Bézier showcase. Okay, here's a Catmull-Rom. Here's Bézier. Note how it doesn't pass through the control points, but it connects the two endpoints. So you can see there's a major difference there, even though these are both using the same points. Cool stuff. Yeah. So we've got another spline and a demo. I'm wondering if there's more that we can do with reuse here. Maybe we can make a function that will do this bit for us and create the debug points. But hey, that's not too bad for a demo. Cool stuff. Okay, you know, I know it's garish. It's ugly as hell. I'm not going to make it better today. But it demonstrates that our curves display what we want to display. All right, I have not done any preparation for this. Bear with me. But what we might look into is another one that, again, if you have not seen this video, go watch. God, I think it's an hour and a half long, maybe longer. Go watch Freya Holmer's The Continuity of Splines. It is amazing. Let's look at the different kinds of splines. There was one more that I wanted to do. I think it was Hermite, but I'm not sure. Right, so Pierre Bézier. So there's B splines. There's Hermite splines. Let's yeah, there's two videos, Bézier curves and splines. Yeah, I was thinking of the continuity. That was the one that like really. All right, we're gonna continuity of splines. Here we go. And we'll look at the chapters and oh gosh, sorry for the ads. ads. We're gonna play their ad for them on my stream. Isn't that fun? Okay. So let's look at the chapters. So Bezier, quadratic, cubic, n degree, spline, not values and not intervals. That's could be useful for understanding. I may rewatch this myself. It's been a while. Okay, and then she talks about the different kinds of continuity. Okay, so Hermite splines, linear splines, cardinal splines. We did Catmull-Rom. So let's look up Hermite splines. Maybe we can do those. Cubic Hermite spline. Okay. Spline where each piece is a third degree polynomial specified, that is, by its values and first derivatives. Okay, at the endpoints of the corresponding domain interval. Interpolation of numeric data. Okay, to obtain a continuous function. Okay, so this is sort of like, you know, you're trying to do some statistical analysis thing. Yeah, I may not be prepared enough to do this. So that looks really interesting though. Look at that. So like if those are the points, or I'm sorry, those are the finite difference tangents. Here's a cardinal spline. Let's look at this closer. So and the squares are the control points. This is similar to a Catmull-Rom in that it goes through the control points, whereas a Bezier does not. Okay, so the Catmull-Rom looks like a specialization of this cardinal spline idea. So there might be a more generic Hermite spline that we could implement. I would love to hear what you all want. So let's see, spline curves. Let's quickly look at this. Okay. Right, so interpolating and approximating curves. Right, polynomials. It's like a math class lecture. Piecewise polynomial curves. All right. Right, I'm talking about continuity. This is the stuff that Freya talks about in her video. Okay. Okay, Hermite cubic splines. So if pi and p plus 1 are two successive control points, for Hermite splines, the user must provide a slope at each control point in the form of a vector tangent. So this is like you have a, so this is it's actually not that different from the Bezier idea, except that the control points are always directional. Interesting. Okay, so in this example, pi is 1, 1, and pi plus 1 is 4, 3. The tangent vectors are 0, 1.5, so it's pointing up. And this factor is going to be, a tangent. You can think of it like velocity in this sense, that there's a directionality to this, not just a directionality, so like not just affecting the position, but also how quickly it's moving. And this is 1, -1. So you can think of like, we would sort of think about interpolating the tangents along the curve. Okay. So we need slopes and parametric forms. We may not have enough information to do. Okay, linear system for the example. 1, 1, 4, 3. I don't know where they're getting those numbers. Needs slopes. Okay, so yeah, this may not be the right resource to look at. We've done Catmull-Rom. Cardinal splines generalize Catmull-Rom splines by providing a shape parameter t. With t equals 0, we have Catmull-Rom. Values of t greater than 0 tighten the curve, making curvatures higher at the joins. Values of t less than 0 loosen the curve. Okay, so this is, I think, related to that alpha factor that we had on our Catmull-Rom spline, which was, we used the alpha of 0.5, which gives us the cardinal, or not the cardinal, the centripetal Catmull-Rom spline. Maybe I'm not prepared enough to do all this. So maybe what we'll do, you know, I mentioned what's wrong there? Oh, I did something wrong with oh no, I didn't. That's from before. Let's rerun and make sure. Yeah, okay. I think it was just complaining about what we'd done before. Okay. I think the appropriate thing to do now is actually make a GitHub repository for this. We're gonna make, just don't show that to me. Okay, new repository. This is gonna be me. Splines. Okay. And we're gonna say implementation of splines in Gleam. Public, no template, don't add a readme, don't add a git ignore, we've already got that, don't need copilot. Okay. Okay, so we're going to make a new terminal here. Okay. So, and then we'll make some documentation and yeah, we don't have a test here. Let's just remove that. We can add some tests later. Nope, nope, nope. Yeah, I know. I should have used the GitHub command line client and gone GitHub repo create. Because that noise is no good. Okay, this is fine. Yep. Yeah, and the nice thing is, you know, only our example has need of Tiramisu. The rest of this is just Vec and the standard library, so that's pretty awesome. All right, let's stage all for now, and I'm going to say initial commit cat Bezier splines. Dimensions, Catmull-Rom, and a tiramisu based showcase. Example. All right. Let's push main and probably watch the test fail, because that always happens to me. Okay, so now what I want to do is really quickly, I think you need 3 for ducks. I actually haven't written documentation. We're going to fix the README. And I may do the rest of this off stream, but yeah, and then we'll get it published to Hex, and then you can download it and use it, and then we'll make more splines. So okay. Parametric splines for use in graphics, simulations, and games. Okay, and then I'm not going to do too much here. Let's maybe say import splines Bezier, and I don't actually know if this name is reserved on Hex. Let's find out. Splines. It's open! Yay! Okay, so why would you include a gen? Never mind. Like, why would you include a gen server? Why do you need a gen server for a spline for cubic and turbulent? Computers were a mistake. Okay, so we're gonna say yeah, let's just make our example really simple. So we'll say let curve is Bezier.new 2D, and then we're going to give it, and we're going to import vec2. Just in case your splines fail, you got to restart. I hate it when my splines fail. Get those under supervision. Okay, and then we'll say Bezier.sample curve, and we'll give it 0.5, and then we'll pipe that to echo. This is going to be our example. It's going to be dumb. Okay, so let's use an example from Wikipedia. Bezier curve. So are they going to give me the numbers on these? Don't care. Give me an example. These are fine, but I want numbers. Yeah, all right. Let's do that. And let's just do 0, 0. Let's make a quadratic one. So another way we could do this is say, let's use their quadratic example here, and this would be like 0, 1, and this is 0, 0. Right, is the control point, and this would be 1, 0. And let's say this is a quadratic we sample the quadratic curve, right? Okay, so it's not that big of a deal. I just want to do this is a demo, like a mini demo. Okay. There's nothing to run. I'm going to delete this development section. Okay. So, help me out here, folks. Well, I guess we can just read the one of these other like documentation, like Tiramisu. That's the README, obviously. Let's look at how Tiramisu does it for any particular module. Okay, so it is 4 slashes. I just made my first actual production ready Unity game. Any tips for future? Do another one. Congratulations, that's awesome. That is such a great feeling, isn't it? I haven't made any production ready game. I do this for the learning, for the fun, and yeah, that's awesome. Congratulations. So admittedly, if you came to my stream looking for mainstream game dev, you're not gonna find it. This is out on the fringes, man. Out on the fringes. Okay, so yeah, you do 4 slashes for docs, and then like if you have inline examples, you can do that. So okay, so we'll do 4 slashes and splines. Popular parametric splines for Gleam. Then it'll be time to abandon. Yeah, that's how my brain works. Spline, and maybe I just like reuse stuff from the README here. Yep. Are often used in graphics, simulations, and games to they can be used to approximate curved figures, define paths for objects to move along, or shape the behavior of various kinematics. Shape the behavior kinematics. That's good enough. And I'm gonna have to put the accent in here. Splines, often used for curved figures. Catmull-Rom splines, often used for paths. Smooth paths. Other splines may be added in the future. Okay. You know the next edition is going to be great when I base my whole thesis. Yeah. I think that's amazing that you are basing your thesis on this fun side project. Useful type alias for vec for 2D vectors over the float domain. Okay. So we've got some base stuff in here. Let's have a look at one of the nested models here. I'm just using Tiramisu as an example of how to structure that. Okay, so you need kind of a short description and then, yeah. This obviously doesn't have any behavior in it, so I'm not going to... I think I might want to link to other modules from here. I don't know how to do that exactly. I used to know how to do it on Elixir, but this needs another slash. I'm going to say in the float domain. Oh, no. Okay, so it is 3 for documentation. This is module level documentation. Okay. Thank you, code formatter, for showing me the way. Linear, we're going to say generalized linear interpolation. So most splines use linear interpolation in their calculations when sampling points from their curve. And I'll say this module generalizes I'm going to say lerp. Generalizes lerp into multiple dimensions and provides example lerp functions for 1D, 2D, and 3D domains. Okay. Type of a function that can linearly interpolate over a domain A. An interpolator scalar multiplication. Okay. Interpolates. I'm going to perpetually mistype that in one dimension over floats. You can use this function instead of lerper when generic type is float. And then we'll do the same for vec3, vec3f. Okay, so we got docs there. Okay. Catmull-Rom splines. And I think that I want to link to some of the Wikipedia pages we've been here, and I'll copy that for now for the Bezier one. And then we'll do that. We'll fix that later. Okay. In your README, Renatius, if you're still here, did you link to specific modules? And how did those get auto-linked? Let's look at your docs real quick. Let's see. No. Sure you want to make it... Yeah. The problem is I want to use those in my own constructions, but if they are internal, then I can't use them in my public type definitions, right? My public type signatures. So I don't know. We can fix that. We can fix that later. Yeah, I mean, if that's the case, then I should be add them into each module. Okay, but then I have to Yeah, I mean, that's, I can wait until NNB adds the alias. I don't know if NNB is going to. I think there was an open discussion about whether that's valuable. I personally think it's valuable. It saves me a bunch of typing. But I can understand not wanting to do it. Like that kind of pins you into, you know, exposing that. I mean, but yeah, stay in bed. Don't do it. Don't do it right now. Think about it. Sleep on it. Don't worry about it right now. Okay. I just want to finish this up so I can, like, publish. Yeah, well, I'm lazy. I'm lazy. Let me be lazy, Renatius. 6 characters. It's not just that. It includes punctuation. Be lazy. Okay. So where do we go here? Okay, so I need to go Catmull-Rom. spline. Uniform parameter spacing. Could look at a B spline later. Yeah, we're going to link to this page. For I think there was a, like, I don't remember exactly what it was in the video, but it's like C0 or C1. They're continuous. I'll just call them, then just call them VF. Yeah, I mean V2F. Fine, I'll do that. Watch me. Okay. So where was I? Preserve velocity through the points in the path. I think that's what it was. I don't remember whether that's C1 or C0. I'm gonna have to go back to the video. Yeah. Okay. Oh, that's very nice, NNB. Thank you. That's perfect. I just saw it. Yeah. You can't see it here on my screen, but I have Discord over on the left. Okay, I'm going to link to the Wikipedia page. Okay. I wish it would, like, wrap this automatically for you. Okay. This is, just call it 3. Yeah, but 3 can't be an identifier. 3 can't be a type name. Y'all are gonna do my head in. Okay, so okay, that's awful documentation. We'll improve it later. Okay. Okay, I'm going to move this one up so it's right below. All right. What do have cats to do with splines? No, Catmull is somebody's name. It's not. I'm not talking about gatos. I'm talking about the two guys who invented this spline, Catmull and Rom. So the spline is called Catmull-Rom. Just like this other spline is Bézier, the French guy. And I'm going to have to put that accent everywhere, so I'm just going to copy it. What did I say over here in Catmull-Rom? Okay. I always hit that key because it's too close to the delete key. Okay, Bezier splines are useful for drawing strokes and shapes and are often the dominant parametric curve exposed by graphical editors. Okay. If you construct the spline yourself, you must supply an interpolator function for the domain. Okay. Given any number of points in the domain. Okay, what do I want to say here? The number of points in the domain determines both the order and the complexity, the computational complexity of sampling the domain. For example, I almost want to make a table here. I don't know if it supports tables. We'll just try it and see what comes out. Order 2 linear, 3 quadratic, 4 cubic, quartic, and so forth. Okay, so 1 is going to be, I'm going to say it's degenerate because it is, yeah, you should not do that. Which makes me think that, like, maybe here in sample, we could put an assert of sorts that checks that the number of points is at least 1. But yeah. And this is, I'm going to put a complexity column on here. Yeah, I don't know if this is going to work, but yeah, there's 4. I don't know that that's going to work. Let's put some dashes in there. I'm assuming that this says markdown rendering of tables, but okay, so this is going to be O1, right? Because there's only 2 points. This is going to be O. I want to think about it in terms of number of iterations, and this is going to be, we'll just say 1 step. I don't think that it's it scales with the number of points. It's actually O(n) squared, isn't it? Because you're gradually reducing the number. Or, no, it's O(n) factorial. Yeah. Except that's not n minus 1 factorial. Because here it's just 1. But for quadratic, it's actually 3. I'm just gonna, I'm not gonna do big O notation on this. I'm just gonna right, because you have interpolate from P0 to P1, P1 to P2, and then interpolate between those next 2 points. So that's 3 steps. For cubic, it's 3 plus 3, so it's 6 steps, right? So for quartic, you've got 4 segments to interpret on top of that, so it's 10 steps on top of the cubic, right? You see how this is going? Using the and here we're going to Castle-Yo method, and I should Castle-Yo algorithm. Should link to that because that's useful. Okay. Okay, and that table looks awful right here, but okay, let's go ahead and document these, and then we can call the stream to an end. Okay. And I'm not doing any check there. I'm going to say at least 1 point. We'll say 2 points, because then it's linear. And we'll say in 3 dimensions. And here we'll say samples the Bezier, and I'm going to have to paste spline at time t using where's the algorithm here, and we'll link to it again. Okay. Panics if the curve contains no points. Okay. I think that's every module documented. And let's look at the Gleam binary. I don't remember. Let's say Gleam docs and see what happens. Gleam docs build. Okay, and we'll open that. Oops. Open. Okay. Get it here. Okay, so there's our README splines, and I wish it would bump up the text. Okay. Yeah, we might hide that. And note this doesn't link to anything, so hey, the table. Let's fix up that table a little bit, because I didn't put okay, and that links to our page. Okay, Catmull-Rom. There's a question here about whether I should make this lerp internal, and maybe that's useful. Oh, okay. So, interesting. Thank you, Renatias, for suggesting that I make that be... the documentation actually uses the one without the alias. So, what I can do is, how do you say internal? Is it like that? You do like internal? How do you hide? Because if I do that, then yeah. It's not going to use my type aliases. Yeah, internal should work, I think. Is it actually like in the doc string, or is it a bare annotation like that? Because I think it's only like the FFI stuff that uses that bare annotation. Bare annotation, okay. The interesting thing is maybe let me look at the lerp module and see what it came out with. Yeah, I think I want. Wait, I almost wish it's fine. It can happen next week. It can happen next week. You're in bed. Just relax. Okay, so I want to say vec to float. I'm going to replace that in here. Then it's not referencing vec3 float. It's not referencing the type externally. In desk, oh jeez. I didn't even mean to make you get up out of bed. For Pete's sake. Okay. Let's build. Let's open. Okay, so now, right. Yeah, I think that this is like roughly n squared. Not exactly. Somebody's probably has it out there and I just need to research it. But okay. I'm tempted to say like I should disallow empty points. Yeah. Oh my goodness. Okay, fine, whatever. I didn't mean to bully you into adding the type alias. I'm okay keeping it internal, but let's make sure we can run build. Okay, Gleam test. Okay, no test found. Yeah, I know. I'm a bad person. I don't write tests. Okay, now I need to find all the places I said Bezier without the accent in the documentation. Obviously, I can't use it in the identifier because who wants nice things? Okay. This is a good place to put a pin in it. Let's build the docs again and just make sure everything looks mostly okay. Oh, what did I do wrong there? Oh, where's the Bezier? I got the order of that wrong. Okay. Yep. I changed my mind. Okay. Okay. I wish I could get these to link. I just don't know how to do that. Okay. All right. Okay, Lustre does link by linking to the hex docs documents in prod. Yeah, I was wondering if there's like, especially if it's in the same module, it might be easier. So like, I could use, yeah, let's do that. Let's do like, I just wasn't sure what the anchor is going to be. But yeah, it's just the new 3D. Let's try that. I think that's an improvement. Okay, so yeah, now it turns pink because it's a link. Okay, and then the other thing I want to do is link to sampling is going to be sample in here. Okay. Yeah, so there it jumps to there. Okay. Catmull-Rom. Yeah, so here I can go in there and add those as well. Those are pretty simple to add. Okay. The That's a good place to stop. All right, let's improve. Oh, and I want to make sure that when we go back here, yeah, the types are hidden now. This is, you know, we could potentially even make the whole, this module hidden. Or put these types in a junk drawer module. Yeah. Imitation. Okay, to prep a release. And we're gonna stage all of that and commit. Okay. Now the question is, I want to, this is not going to be 1.0. This is not 1.0 quality. We're going to go back to 0.1.0. Gleam.tunnel. Let's just make sure it still builds. Docs build. Okay, and then it goes 1.0.1. Okay. Bump to be 0.1.0. Okay. And I'm going to get tag v0.1.0. And then let's see. See what publish does. do anything in hex. No. I am not using semantic versioning. Wow, it shames you. Holy cow. Missing license. Okay, so okay, I'm gonna put this in the description. Yeah, and I need to make these. So licenses. I'm gonna use the MIT license, which means I need to get the license in here. So I didn't push that tag, so is it tag delete? Okay. Let's get MIT license. Da, 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 da. Okay. Let's make a new copyright 2026 Sean Cripps. Okay. Okay, and then in here, type code Sean Cribs, Splines. I know this is like not riveting content, so if you've dropped off of the stream or the YouTube video, I don't blame you. Okay. Did I push that already? Ugh, such a bonehead. Okay. All right. So let's. Okay, now I've tagged it, and now we're gonna do Gleam publish. I am not using semantic versioning. Sure. That's the password. Yep. Okay. Woohoo! There we go. And we can go to the documentation. There it is. We've got all the stuff. Good stuff. And yeah, share that in the Tiramisu. All right, thanks for hanging out. And we may do some more splines next time. We'll figure out, I'll do some research on bee splines and hermite splines, and maybe we can get those in there because those are also useful for different things. So thanks for hanging out, and I will see you next week.